Right. Yeah, so I want to talk about the components of what this metric would look like, but I want to give it from a perspective of home builders and also architects and potentially the HERS rating community. So Tim and I have been focused the last couple months looking at, what are these Lego blocks that could, be placed in line so that we can start evaluating this metric. Obviously, this is a work in progress. We know there will be some challenges, and we're looking from the audience to help us figure out what are some of these challenges that we haven't foreseen just yet. So the sort of the two factors that come into play here, there's obviously the traditional aspects, which Tim sort of talked about, the temperature and the things that a human feels within an environment. But there's also factors that the builder and architect can actually implement changes to affect comfort. So when we talk about the architecture and the design of the building from a volume standpoint, those things need to be placed in consideration. Then we talk about the typical factors, which is the enclosure design that we're all used to looking at, and also the HVAC design and how they're integrated together, because I think that becomes very important to looking at a thermal comfort metric. And then lastly, which is the most difficult part of this, is how do we consider occupants living in that home, but also living in that design of the home? So we want to talk about those aspects. So simply just, what are the traditional aspects of comfort? So we got environmental factors, which is temperature, which is airspeed, humidity, and radiant heat. Temperature, everyone understands temperature. It's basically the temperature that's surrounding the body. Airspeed, it's, what's the airspeed that's coming out of a duct? Is it stagnant or is it moving? Well, those differences can affect how you feel within the space. And humidity, obviously in a high humid room, you may get sweaty. So these things we need to be considering. And then radiant heat. So we want to understand if a room has a lot of glazing and you're standing in front of that room when it's really sunny outside, what does that mean to that human? And then obviously the personal factors. This is varying on the individual. My wife, she's very fit. She tends to put a lot of clothing on in the wintertime. Versus me, I got a little bit more insulation on my body, so I don't need the sweater. So these come into play. So even within a home environment, we've got two different occupants with two different metabolic rates. Architectural design. So this is something that I believe we haven't looked at as production home builders in the industry. The volume and the orientation of these homes have direct impact on comfort. Some of the homes that Tim showed with some of that data sort of plays into this aspect where the volume of the house, the townhome 3-story, we had a lot of stratification, stack effect, and then the other home was a little bit different. So, how these volumes are shaped and how they're oriented to the sun plays a large role in understanding comfort of those spaces. Building enclosure design, we have been focusing on this area probably for the longest period of time, understanding enclosures, how tight we can make it, what are the R values to consider when putting in a really good enclosure. We also, some of the new things that we're trying to look at is air leakage. We've been tightening homes for years, since the 70s, like what Tim was talking about. But how far do we go? That's something that we're trying to understand. How far do we go? How tight do we make it before we start adding ventilation? What's that sweet spot? And then these other factors. So solar management, I think, is a key that we need to start looking at with home builders when designing elevations. How much windows do you place that are facing south? And then from the inside of those rooms where you have a lot of window, what is the floor area of those rooms? Because when you have more window area versus floor area, we get into some issues with overheating or overcooling. So we have these issues. And then we have these mass lag effects that we've been seeing, especially with low load homes. And then lastly, from the architectural design, I think in my years being here at IBACOS for 15 years, walking building sites, I have never seen an exterior shading device on a home. I think that's going to be more important as we move forward with understanding low load homes and how they perform in regards to comfort. All right, HVAC design. This is an area that IBACOS has been focused probably the most in the last 25 years. But understanding what type of heating and cooling system the builder wants to implement in this home and the capacity is very detrimental in what we're trying to do here. Obviously, we've had this oversized versus perfectly sized for many years, and I think the industry is getting better at actually sizing these units according to the right manual J. So, but these are things that the metric will have to consider through ACA manual J, manual D calculations. Duct layout, these are obviously, with both of these, we want to make sure that this whole system, ducts and space conditioning, is in conditioned space. When you start having these equipments outside of conditioned space, it brings up a lot of other issues. Separate from comfort, brings up issues with regards to energy. So on the duct layout, you know, we're looking at duct temperature gain, duct leakage, which has been common in the HERS industry for a long time. Air balancing, this is one that really bugs the hell out of me. And I think Tim too. So Tim, from the commercial aspect, you see balancing dampers everywhere.
Absolutely, and literally it does drive me nuts when I came into the residential side to see the lack of that in many cases. So we're going to focus on that.
Yeah. So that and we always try to design a duct system with have some type of balancing control, so we can make sure that those rooms are getting the right airflow that we design on that manual J and manual D calculation. And then the last one, I think, or the last two, sorry, diffuser placement and diffuser air throw and selection are critical, because the volume of air we're pushing through this house in a low-load home is probably half the amount of air that we've typically pushed. Actually picking that diffuser and making sure that that diffuser can throw air with that certain pace velocity is going to become critical. Room air balancing. So when we talk about HVAC systems, we want to make sure that each room, and typically we see this issue in bedrooms, where, you know, people tend to close their bedroom doors when they're sleeping, and if you don't have proper return air, you could sort of suffocate that room. Like that girl is blowing air in a balloon, she can only blow so much air in that room if there's no relief. So that's where on that bottom picture, you know, we have strategies. We have transfer grills, we have dedicated returns if necessary, but there's also the doors versus open. And then door undercuts. I think that should be eliminated. Undercutting doors to allow that pressure relief, I think, is something that we should abolish it from the acceptance of the code official. So programmable thermostat. This has been something that we've discussed many times here at IBACOS. In a low-load home, does it make sense for a programmable thermostat? I think 50% of the IBACOS folks say, yeah, it's necessary. But in a low-load home, we've got these ramps and drifts that happen when a homeowner in a low-load home uses a programmable thermostat. So what do I mean by ramps and drifts? Well, if you set back your thermostat in a low-load home in a really cold day, say 5 degrees, that home will actually take a while for it to cool off. But then when you want that home to get up to the temperature, it's going to take almost the same amount of time. So it's going to have a long drift to get the temperature. So why do it? Why not just keep it at a certain thermostat set point and not have to worry about it? And I think ASHRAE 55 talks about ramps and drifts criteria, so obviously we're going to consider that as in part of the metric. Room by room zoning. This is an aspect that if we want to try to maintain comfort in each room, we may have to consider zoning room by room. So we, you know, looking at what the automotive industry has done, and this has been done for over 30 years. Just a sample picture on the left versus where we're at today, where, you know, you have multiple climate zones within a vehicle. We should have the ability, the homeowner should have the ability to change the comfort in their bedroom or in their living room or in kitchen. Ventilation. So ventilation, obviously this has been a big sticking point with home builders, trying to focus on what is the actual system that they want to implement. We've heard you know, many instances from builders, you know, do I have to do balanced, do I have to do unbalanced? Should I do supply versus exhaust? Obviously, all these scenarios have impacts to comfort. If you're direct delivery, you're bringing raw air into the home. Well, what does that mean for comfort? Well, it could impact comfort, especially if you're dumping raw air into bedrooms. we believe preconditioning the air and then balancing that preconditioned air to the whole house is the best approach. So these are factors that will play into increasing or decreasing the metric score. Occupant behavior. So this is something that we have been looking at, especially on the design side of the home. So when a builder is designing a home and the floor plan is an open layout, and basically you're saying this is going to be an entertainment area. Well, we should think of, at that point, the builder should think of what's that mechanical system design, because that homeowner is going to use that space for a party. And in those party instances where a lot of the HVAC contractors get that call, hey, I had a party, I couldn't get my system to cool off fast enough. Why? So looking at those areas to be zoned to make sure that you create a confidence level with the homeowner that we can maintain comfort. Occupant confidence is sort of related. So we want to make sure that the occupant is confident. He's got everything at his fingertips today with the apps and his iPhone and the technology. He's got instant access to internet. Well, why couldn't he have instant access to comfort? I think that's going to be a psychological aspect that homeowners are going to want to have, and they're going to want to trust the home to meet their expectations. And home builders should trust their built product that their homeowners will value. So that's on the component aspect. So the next part is, basically gave you a quick snapshot of all the components. So what does it mean for us, IBACOS, to move this path forward within the industry? So obviously this is the first part of getting the buy-in from the builders and also from the industry. And when we're talking industry, we're talking manufacturers, we're talking HERS raters, anyone that's involved in sort of the HERS rating system today. We want to get to an understanding, are we missing something in regards to the challenges that we may face? So we need that to proceed. So I think Tim wants to talk a little bit about some of the, he's calling it the foundation metrics.
Well, IBACOS, and I'll go through this quickly, but IBACOS has done work on comfort for many years. And so we've slowly been developing ways to look at comfort and quantify that. And we've done this on the psych chart. With we had a thermal comfort performance index in the past, which is probably going to play some role in the TCRM. But we've looked at comfort in a variety of ways to look at frequency of occurrences as well, and looked at all kinds of crazy plots to describe comfort and the limitations on what is considered comfortable and not. And we've created visual graphs that are as detailed as we want from a data perspective, but also give a quick impression, and we turn those into a sort of a yes/no chart, or a red-green chart as we call it. And something like this can actually feed very well into a simplified metric such as the thermal comfort rating method, ending up with a simple comfort index. So where are we at today? So Building America has outlined some roadmaps that looks at the next basically 4 to 5 years. And three of the things on this roadmap in regards to space conditioning is developing this design procedure, tools, and comfort metrics for low-load homes. So that's in the development over the next 3 years. They want to validate, demonstrate comfort system solutions in low-load homes using these metrics and these criteria. And then lastly, in the last tail of this roadmap is what are the system designs criteria in low-load homes. So we believe this plays really closely to what Building America wants to achieve in the industry and with their government programs. So we just want to make sure that we bring this metric to the market in the best way, efficiently, and to bring everyone in the industry along the way. So from here, we want to submit the business case to DOE to get an understanding of what the model funding support would be. Obviously, we want to continue and conduct additional research and develop what would be the weighting of all these components, because that'll play a big role in what that final number would be, if it is a final number. And then what are these design considerations that I talked about regarding the architecture, enclosure, and the HVAC system that will play an impact in this metric. And then obviously where that home is located is critical.
for, cold climate zone versus a hot humid versus a hot dry is obviously important to understand. And then lastly, how do we model out those occupant considerations that we foresee today and with the future generations to come?
So Anthony, the business case, would you see that being a lot of the stuff that Tim talked about earlier up front in terms of what the need is, then perhaps also the feedback from people who are on the phone and others in the industry, other people in the alliance, to say that there is, in fact, from a market perspective, beyond our perspective, a need for this as well?
Yeah, I think from our perspective, the builders are probably the key sort of crankshaft. It has to make sense for them as a business. We want to make sure that it's the right thing that they could actually sell, and that occupants want them. But also, we want to get get the feedback from the industry so that we can basically tell that to the government on what we think and the industry wants to see. So that's our next steps. So in this process, obviously, Building America has done a ton of research in low-load homes and comfort conditions. So there's a lot of sifting through old Building America reports that we want to do. We also want to look at, what's the software challenges that, this industry will face with this metric. Obviously, RESNET for HERS uses the REM rate modeling and other tools. How does it affect that tool? Or is there a new tool that needs to be developed? We don't know that yet. And obviously, we want to partner with RESNET. I think that's, they're the one that's going to push this out to the industry. And we want them along this journey. We want to make this a successful collaboration with all parties. So these are just some of the sort of parties that we want to start interacting and collaborating together with. Obviously, us as IBACOS, the leading builders of America, they're a key component to this. Our manufacturers that are in the alliance, but also beyond the alliance, DOE, ASHRAE, ACA, and the code councils. RESNET obviously has a process that they go through to develop programs and metrics. So,
and one being developed right now is the water index, the water metric, and so we've shown a sample organizational chart of how the TCRM process could develop following what they're doing right now with the water index.
Yeah, and so from our perspective, we're really excited about this. It's taken us 25 years to get to this point, but we're very excited. We want to move forward.
Absolutely.
Can you guys speak to the importance and, in parentheses, ratio of all of the comfort variables, temperature, mean radiant temperature, humidity, etc.? Do you have any thoughts on that front at this point?
That's a good question.
So sort of the weight of each of those?
That was the question. Well, it was not set as weight, but it was, I guess that would be the weight.
Yeah, it sounds like
importance and ratio together, I would presume would be.
And so that's a good question, and to summarize that, I'd say the physics of this takes up a lot of it, but there's the psychological aspects of it which are also going to take a factor in this. So I lump everything there in the physics bucket.
Yeah.
And we need to explore that.
Okay, and there's a people factor statement here. It's a question, but it's also a statement. It sounds like we've done a lot of research on thermal comfort, but isn't there I'm not sure what this word is, so forgive me, I'm going to skip that. Isn't there a thermal comfort unattainable level that can't be achieved due to the variability of people? So the people factor. So can a single number really cover all of the issues?
Yeah. So we talked about a reasonable set of criteria. So as part of this process, we'll have to define what that is. And when IBACOS worked on the TCPI, the Thermal Comfort Performance Index, I think is what we had called it, we talked about the percentage of time within a comfort envelope, recognizing there's going to be time outside of that, and that's okay from the sense of trying to get the bulk of hours in it. So understanding that there's going to be those outliers, but this is really about the ability of the home to provide sort of that central area of comfort, meaning the bulk of the hours inside some defined comfort envelope, but also the ability to sort of stretch that envelope. I believe the envelope isn't the same for everybody or for every house, and so the envelope that we typically see on the standard 55 site chart may not be the same shape for everybody. It could be squat and long and short, or it may be skinny and tall.
Yeah.
And I think that the ability to change that envelope and apply this factor going to be part of what we look at.
Yeah, and I guess if you would ask that question, same question during the HERS process, we see that today. You know, we got a score, but a homeowner can add space heaters and increase energy. So we'll probably see those same issues. I would, no doubt in my mind. So we have to be cognizant of those issues.
Yeah, and that's really what makes this exciting, is there's so many factors to it.
Yeah.
Cool. Well, someone was happy with your answers to their questions, so they said, got it, thanks. And then another interesting question, which I was wondering about myself, is, you know, obviously thermal comfort is part of it and all of those factors that weigh into there, but there's a question about whether we would include sound and smell, which as an end consumer are also big comfort issues that would play both into the enclosure and the HVAC system.
So this is Tim, and I completely agree that total environmental quality is a big thing. In the commercial world, we talk in those terms. In the residential world, I think it's potentially even more important. So we're starting to develop this whole series of what we think these metrics in total environmental quality, including sound, smells, vibration, and other factors, lighting. You know, from a total quality standpoint, I believe we need to address that. It may not fall in this particular metric, but I think what we learn going through this process could inform us on some of those other factors.
Yeah, and if those factors are important from the industry, we should at least document them and see where how we progress with it.
Will there be a different comfort level in the summer to winter due to the amount of clothing? And I find this personally, you know, I think that makes perfect sense. Due to the amount of clothing people are used to wearing. So the set point, for example, you might have in the winter is different than the summer. And let me see if example, more clothes in the winter make comfortable at lower temperatures. Yes.
Correct.
So what do you guys think about that?
That's part of the variability in the reasonable range that we'll be looking at. I mean, if someone is wearing a down coat in the summertime, you know, we're probably not going to be addressing that sort of situation. But I think that's a very unrealistic situation to be looking at. This index is the ability of a home to meet a generalized, you know, a broad but generalized comfort envelope. So it with the house more than any particular owner's preferences. The more a house can respond to dynamic requests from owners, the better the score. I don't want to higher or lower, but the better score it's going to get in this index. So it's certainly something, we don't have the answers to that, but we certainly know and we appreciate that kind of input because it helps us focus on the things we need to look at.
What will be required for field measurements to verify compliance?
A whole lot of sensors. A lot of sensors.
Or a lot of measurements taken, you know, during commissioning.
Yeah. So we're gonna run out of time for all the ideas that we have in that area, but the deployable sensors that can be there for a short time to do short-term monitoring and actually establish a representative section or selection of data is going to be something we consider in this. So the answer is too big to respond.
I think we actually have one more poll on the next slide, which is perfect timing because it seems like we've got, you know, quite a bit of feedback from you guys. But we wanted to get a sense, gauge everybody who's on the phone still, and thank you everyone for participating today and sending some initial questions to us. But we wanted to get one final poll with you. If you think a simple comfort index would be beneficial to the housing industry. So I'm going to share that with you. Or maybe not. It's clicked on the wrong one. Sorry about that, folks. Do you think it would be beneficial to the housing industry? And we know, you know, based on conversations we've had with you, there are a lot of variables to deal with. We just want to get a sense of whether this is something you guys think should be embarked on in general, because that will help validate that it's something that we should look to explore, and we'd be interested in engaging anybody who's on the phone in that process as well. So,
so it's interesting. Can I respond to the result?
Yeah, well, let me close it real quick and let me share it.
Because we were really close to what we thought it was going to be, 60-40 split.
So,
So, good.
So